Welcome to my class, guys. Genetic and inheritance blood grouping past examination paper. So today we'll be doing yesterday's correction and some of past question papers 2015, 2021, 2022, 2023. So let's hope we'll have time to cover all of those questions that I went out there and find for you guys. So today's date is 26 March 2024 and then time is 6:11, right? So good morning. And then from there, guys, we are doing blood grouping. We did blood grouping yesterday. If you missed the video, go back, go and watch that video, guys. And then today we are also going to do a problem solving referring to sex determination, sex linked inheritance and blood grouping, right? So you will agree with me that yesterday I did a revision, a format of a genetic cross and diagrams, like I did all this on previous revision. So if you missed that, guys, go back and watch it. I only saw 16 views. So it means that maybe 5 of them, there are those who are watching my videos to the full length, and then after that they prepare something else. And then today we'll be here past examination papers. Ne? So okay, thank you. We're at week 2, and then we did our Monday, we did our plan Monday, Tuesday, Wednesday, Thursday, Friday, those who attended yesterday. And then we said Monday we'll do introduction, or we'll do the blood grouping. Tuesday we'll do question and answer. Wednesday we'll do dihybrid. Thursday dihybrid. Friday question and answer. So this is how we are heading, or this is how we are moving, right? We're at week 2, blood grouping. Why we did blood grouping, go back to my previous YouTube video and then you will see. Ne? And then from there, our examination guideline only needs, doesn't need more antibodies and what. Just know that there's a different blood groups, and then these different blood groups are the results of a multiple alleles. Then when we talk about alleles, this multiple alleles, it may be this one, or can be this one, or can be this one. Where I said here, it will be the dominant A, or the dominant B, or this one we can refer to as recessive, but this, it's an empty chromosome. We can say this one is an empty chromosome. In a chromosome, there's a locus, and that locus is empty. I will explain it further when I go to the next slide. And then by say the genetic problems involving inheritance of blood, this is what we are going to do today. Ne? And then we also said that combination of A, B, and I, it results into 4 blood group type. Ne? So today we'll also cover the group type. So okay, before I can come to this, before I can come and explain what I prepared here for you guys, we have 4 rules, 4 blood rule, 4 blood rule, or 4 rule of blood, ne? And then some of them, they will say 1, 2, 3, 4, because this is an explanation of blood. You will say 1, 2, 3, 4. Then here what you are going to do, you said 1, you are going to say 1, 4. Each and every individual, we have 1 group type. We have 1 group type. And then number 2, all of us, because we have 1 group type, we have 2 alleles for blood, ne? For blood. So it means that it's either you have A or B or I. Combination of this. Of this combination will result into 4 group type, which will be A, B, B, and O. Then this, there's a possibility of this to be like this, or to be like this. And then B, there's a possibility, only A possibilities when they are this. And then here it can be like this or like this. And then O, it's when we have chromosomes that have nothing. I'll come and explain this. And then we know that from there, these blood groups, they have a group type A, it has antibodies for B. And then if we mix B and A, what is going to happen? The antibodies at blood group A and antibodies at blood group B, they are going to attack the red blood cells. We have red blood cell, white blood cell, plasma, platelets, and everything. So let's go back to our blood rule. And then 2 alleles for blood. And then this, we are saying number 3, we are saying 3 alleles. 3 alleles control the blood group. 3 alleles control the blood group, which will be 1A, 1B, this one. And then number 4, we are going to say resulting in 4 blood groups. So you see, so it's 1, 2, 3, 4, rule of blood. Rule of blood, or blood rule. One group type, H an individual. I have one group type, I have 2 alleles, and my group type is controlled by 3 alleles, and then those 3 alleles, they result in 4 group type. So let's move in, let's come here and explain it. Let me just waste 10 minutes of revision, and then here we'll explain it. Here, this is how multiple alleles, it means that there's 2 or more alternative. In this group, in these blood chromosomes, there's a possibility of you to get this 1 or 2 or 3, and then there will be only 2, one from the mother, one from the father. And then here's the thing, we are going to say one chromosome here, if it's A, we're going to do like this, and then this one will be B, and then in this locus, the allele will be for B. Then it means that maybe, for example, we find it like this, and then here we will have nothing. Here will have nothing. So it means that if we cross this and this, the A thing is going to be coded, the blood is going to be coded with A antigen. What am I talking about? The red blood cells. You remember yesterday I did an illustration like this, and I said red blood cells like this. These red blood cells, they have the antigens, and then if they don't have antigens, it means that you have a blood type O, and this means that you didn't inherit neither A or B from your parents. You inherited nothing, but the chromosome was there, but the chromosome came with nothing. So if we are saying A, here we are going to be like, where we are going to have something like this, and we are going to say the blood is going to code for A. It means blood group A, we are going to have, I talked about this. If you don't get this, go back, guys. Go back to our class. And then I talked about this. I only want to spend 10 minutes on this. So if we are saying with B, when B, it's when this and this merge, and we can have B and B. Because we only have B that is active and the other one there is nothing, we are going to code for a red blood cells that have antigens B. Antigens B. I talked about this. And then when we have these two alleles together, we are going to have a red blood cells without antigens. And then these blood groups, when we determine that it is A, it is B here, it means that in the plasma, in the plasma there is an antibodies for A here at B. And then let's talk about when we have A and B, it's when we cross these two. When we cross these two, we have A and B. Let me get space fast. We have A and B. So what does this mean? Because they also, so these are the co-dominant. It means all of them, they are going to express their phenotypic thing. Where are they going to express their phenotypic message? Where are they going to express their phenotypic information that is carried in this allele? Then we are going to say it's a red blood cell, and this red blood cell, because all of them, they are co-dominant, we are going to see all of them present at this moment. We are going to see those who are coding for B, and then A, B, A, because they are co-dominant. B, A, then B. Then let's put A here. Then here's the thing. Then because they are co-dominant, why are we saying they are co-dominant? They are all expressed. And then the other 3, they are complete dominant. We talked about this. And then they are complete dominant, because when you have A and the small letter A, this one will be dominant over this one. And then here, when we have them together, they are going to co-dominate, they are going to cooperate, or they are going to have same share of the antigens we are going to have. And then in this blood, because this type of cells, they are roaming inside the blood, it means that this blood, it does not contain no antibody. It doesn't not contain the antibodies, neither for V, which is A, or neither for O, for B, which is here. Because if these antibodies, they were there, they were going to attach at these antigens, and we are going to cause a clot. And then at group O, because this one, it's nothing there. At that chromosome, there is nothing. we are going to see the red blood cells that have no antigens, and it means that because there is no antigens in this blood, we are going to have a blood that have both V and O. Because either way, whether they are there, they are roaming around, it means that they are not going to attack these red blood cells. So at A, we are going to see antigens for B, and then at B we are going to see antigen for A. Ne, vice versa. For me to survive there, it means that there should be something that's not attacking me. Thank you. That was my 10 minutes labs. Let's go and do activities. Let's go and do our activities. And then I gave you, then we will come here and say correction. I gave you this, go and do this. We talked about how to cross, how to do everything, and then we said we can use this to identify the parents and the parents' identity, paternity testing, something like that. And then we talked about how do we exclude, how can this be used to exclude a male as a father, but it cannot 100% conclude that that male is the father of that child. You get me? You still remember me? Then we are saying to get correction, today's date 26/03/2024. Then thank you guys. And then number one, those who wrote, those who didn't write, let's do it together. Number one, if the child has blood group O, you know, for at this time I told you last that they are no longer going to force you, and they are no longer going to feed you with more of information. At this time, you know, when we have a recessive something, the two has to be there so that the recessive one will be visible at the phenotype. So but the mother blood group is A, we know it can be like this or it can be like this, depending on the information that we get. And then the information, because the child has the blood group O, it means this one is going to be excluded, because for this child to have I, small I here, it has to get the small I from the mother. And if the mother is like this, it means Mwanawa belongs to this family totally. We are having a white boy. I also have this meme that I saw. I'll send it on the group. Remind me, those who are watching this from the group, remind me for the meme. And then they say, would the man with blood group AB, we know this one, it's heterozygotes, only these possibilities. And then Barry, would the man with blood group AB be the father of that child? Use a genetic diagram to explain your answer. And then, will this man be the father? The answer is no, right? From our understanding and our explanation, before we can go and explain anything, our understanding is say no. Then what do you mean? Since you are saying no, use a genetic diagram to explain your answer. Well, when you are giving the genetic diagram, you will be explaining your answer. How will that be possible? You are going to say, okay, P1, and then you say phenotype. You know, when you write everything. I told you, when you write everything. You're going to say phenotype, and then phenotype will be a blood group father here. It will be AB, male, crossed with, let me have space, let me write here. Let me write there. I'm going to write there. Okay, I'm going to say P1, and then phenotype. This is what you have to write. I'm going to write the full thing here. And then phenotype, we are going to say AB, male, crossed with a female. And then you are going to say a genotype. And then you are going to say A and B. Multiply with A. For you to write this, you're going to have 1 year, because you understood the assignment. You understood that the mother here has to be like this, because you know with this phenotype we can have A. For you to write this, we give you 1, and you are explaining. You give you, and then this will go meiosis will happen, and then we're going to have gametes, and then these gametes will be like this. You just separate. And then this information, you are also going to use it during dihybrid. So know this, dihybrid. And then from there, we'll say fertilization. Previous years, they used to say fusion here, but it's fertilization. And then this one, fertilization, you can use the arrow method, or you can use the Punnett square. you can use the arrow method, you can use Punnett square. And then there you'll know fertilization, and then we'll have F1. This is what you have to write. Then F1 will have genotype. You know if you are P1 it's at the right, and the F1 you know you have the mark. If meiosis is and fertilization they are at the right place, you have the mark. Then genotype, you'll say A and A, it will be A and A. You know, when I explain from here, I don't write this phenotype, I just cross and then we move on. So okay, and then another one, this and this, then this and this, it will be 1A and small letter I, and then B and the small letter I, it will be A, B, and then B, and the last one it will be B and I. So use a genetic diagram to explain your answer. I agree you said no. I said no, Anir. Then you may start by answering question no, and then you explain this, and then at the end you'll then conclude, Akir. This is the completion mark you'll have to use and this to explain, and then you'll say a 0% chances of a baby, of a child to be type O. Then hence the father is not the parent. You might be the father but not the parent. Again, then that will be your 6 marks. Compulsory mark, it can come with this it can come with this explanation, and then you will have to say will the man with blood group AB be the father of the child? No, you get it, and then the explanation, you get your 5, and then the chances here, maybe they will need that chances to show where are you saying this no. Then from there we move on, you understand. And then number 2, but human blood groups are controlled by multiple alleles. List all the alleles that control the human blood group. You know it's A and it's B and it's I. And then how many of the alleles named in A can any individual inherit? Only 2. You inherit only 2. You can, it's either A, B, A, B, A, but you will only inherit 2. Why? Because the factors, they separate. So during segregation, they separate and then make sure that each gametes have 1 chromosome. And then number C, give a reason for your answer. That's the reason that I was giving here. That's the reason that I was explaining. And then that what I was give the reason is because right now you will have to explain that thing, because segregation, due to the principle of segregation, 2 factors, they are separated so that 1 gamete have 1 factor. So it means that now as a child I have 1 gamete from the father and 1 gamete from the mother. Then it's 1 mark. So you just give a small explanation. You can say a one individual inherit 1 gamete from the father and 1 gamete from the mother, which results into 2. Then number D, which 2 alleles are co-dominant in the inheritance of blood? They want 2 alleles that are co-dominant, and those alleles, it's A and B. And then number E, a man has blood group A and his wife blood group B. Okay, we know now we know the possibilities. It might be AA or AI, depending on the. And then but their first child has blood group AB. Possibility, yes, because in this scenario multiplied by this scenario, there's a possibility of this and this. There's a possibility of this and this to merge, hence this one. And then the second child blood, it's blood group O. Because now we have a blood group O, that forces us to say yes, the second, then we cancel this one. This will be the second because there's a possibility. Then this, when this and this meet, we have this baby. And then what can one conclude about the blood groups of these future children? What can you conclude with this? Now we are concluding with this, and we are concluding with this, and then we conclude with this. These crosses will result into 25% chance of a child having all type of blood group, something like this. All type of why? You cross this and this, you have A and B. Chance number 1, and you cross this and this, you have A, I. Chance number 2, you cross this and this, you have B, I. You cross this and this, you have I. So you have 1% of A and B, 1% of blood group A, 1%, 1 is to 1 portion of 1 is blood group B, and 1 of this. And then when we go to proportion ratio, since it's 1 is to 1 is to 1 is to 1, it results into 25% of each possibilities. You are 3 marks, you get it. How you explain it, it's how you explain, but they just want what one can conclude. This one, you can conclude this based on these crossings. Ne? The next week we'll do dihybrid cross. Tomorrow I will do dihybrid cross. So today, let's go and do other questions. So here we are done, guys. Then we can go to, this one is a study guide. We can go to 2012, as you can see. Grade 12, 2015 March. And then in this question paper, let me see, where did I wrote? Yeah, I did there. In this question paper, I saw some questions also. Let's go and look for them. Why not? If you have this paper, you can go and look for this paper, maybe the hard copy. Even if you don't have the hard copy, you can go and request a question from your teacher. The school is not a budget for you. The school have a budget for you to request these question papers, hard copy. So here it's a dihybrid cross. We'll do this tomorrow. Don't worry much about it. We are going to move to 2.3. I told you guys, these questions, they come based on how we are teaching you. You'll find this at home, question 2.3, 2.4, monohybrid, and the genetics and what. Then 2.3, here's the question. It reads as follows. How to deconstruct a question. The question is out of 5, 6, 7, 8, 9, 10, 11, 12, 13. Ne? Out of 13, then when you are begging 13, or maybe let's just take 10, or let's take 7. It will be a fair 5 nika. So the question says, you take your pencil, put your question down, or your pen, or I prefer pencil because a pencil you are going to understand. This is what they want us to teach, to how to decode a question paper, how to read what is needed in question paper, because you guys, you end up cramming the answer or end up coming up with something that we don't understand. And then you will sing these songs. They will produce the songs, those teachers that sings life science, and then we'll come and sing this year and see if they correspond. Then 2.3, Mr. and Mrs. Ponela. Is it Ponela or Fonel? Mr. and Mrs. Fonela, this is the married couple, are concerned that their baby girl does not appear to resemble either of them. You see? It means the guy here is complaining on this one. So the moment now we know that we can do a blood test. Okay, let's move on. They suspect that the baby they were given at the hospital was not theirs. It's not like they are not trusting one another. My scenario, my hypothesis, my conclusion was wrong. It's just that they are suspecting that the baby they were given in the hospital was not theirs, and also that is also a good reason to start this thing again, because you don't want to come out to your married woman as someone who doesn't trust that woman. So you'll end up coming with the reason or maybe they give us this baby, they give us a wrong baby from the hospital. Ne? But the guy know, because the baby, I will send that picture also. Because the baby is black and both of us we are white. The baby is black. People at the hospital, they make sure that they give you your baby. If the moment the baby comes out, they wrap the baby at the hand with the ticket name, your mothers and fathers and everything. So just that the guy was here trying to, okay, it's fine. You see, you play with those scenarios, and then from there, Mr. Fonela or Mr. Ponela is blood group AB. We see AB, it will be like this, and Mrs. Ponela is blood group B, and then she's blood group B. That there's a possibility for another one, so let's wait for that one. And the baby they were given, it's blood group O. Then this one, it will be like this. because ngwana o ke wa fonelwa. Either way, because better there's no way you can say maybe this one is B, and then this also out of this conclude that ngwana was wow, as this not their baby. Both of them, it's not the baby for the mother, and then it's not the baby for the father. So both of them ngwana was one. So it can be like this, or if meo ke ngwana, this baby, it's the baby is it's Mrs. Fonela's baby, but Mr. Fonela is the one that is not trusting the mother. The combination can be like this. Where did the baby get the small I? He got it from the mother. But if the mother doesn't have it, it means that ne, but okay, 2.3.1, but give the possible genotype of Mrs. Fonelwa, but mark 2 marks. They are not there. They are not crazy. They are saying 2 marks because they know that if when you did your correction or what we were doing previously, we know that there's 2 possibilities, which are, it's either she can be like this, or there are possible genotype, or BI. And then the baby girl, they said 1 because for the baby girl to be O, we only want this. Then you have 2. 1, 2, 3. 3 down, 4 to go. And then 2.3.4, explain why the baby girl with blood type O cannot be Mr. and Mrs. Fonela's daughter. Explain why. Give us an 3 marks. Give us an explanation why the baby girl with blood type O cannot be Mr. and it means that this baby, she's not, the baby girl, she's not either Mrs. Fonela or Mrs. Here's the explanation. Because the baby, you can start there by saying because the baby, or you must start that let me see, where did I write it? I didn't write it okay, we can say because the baby inherited, you explain it the way you want to explain it, Hanel. Because the baby is she inherited both I and I, ne? And there is no possible way that Mr. Finelwa can produce or can give that baby an I. It means that we are excluding Mr. Fonela as the father, ne, in this situation. And then you can get 2. And then another one you have to say, and there's a possibility of Mrs. Fonelwa to be blood type B with homozygous dominant. And with these possibilities, since she cannot also give the baby girl an I, this results as girl being excluded as the as the daughter of these 2. Ne? They are saying both of them. Hence they say the answer is 3. They say explain why the baby with blood group type O cannot be Mr. and Mrs. Fonela's daughter. She have this and this, and she will need both from the boy. She will need this. She will need both of them from the parents. It means she got 1 from the father and she got 1 from the mother. But since Mrs. Fonelwa, there's a possibility of her to be this combination. These chances now, they are excluding the baby more. Let's move to 2.3.3. And then we beg another 3, or we can beg another 2 there because the explanation can be vala, or you can get 1. Then now you have 4. Ne? And then you go to 2.3.3. But explain why the use of blood type for paternity testing is not conclusive. Because most people have same blood group. 1 mark. Because most people have the same one group, now can be having a same blood group as someone else. And if that person is going to test for blood group containing the paternity of him being the father to my child, the possibilities will be there. For an example, Mang, the other guy is like this, and then my wife, she's like this, and then we are going to say our baby, she's like this. And then if we go and test this guy here, there's a possibility of him to be the father. And also me, this side, who is like this, you see, who is like this to my wife, and then this I can go and match with, and then the girl, I can also be the father to that girl. So you see, with blood grouping, it's only exclude. We can say this person is not the baby, this is not the father of this child, or this person is not the mother to this child, but we cannot 100% conclude that this mother is 100% mother to the daughter, and this father, he is 100% father to the daughter. I hope you understand this. And when you understand the blood typing and the blood grouping thing, this will be very much simple. And then they can also give another question: explain why we have to test blood before blood transfusion. Ne? And then explain why the father can, maybe they do like this example on it, this Miss Fonelwa and what, and then they say explain why Mr. Fonelwa cannot donate the blood to the baby. Get me? That's the question that they will bring with you understanding this blood concept. Ne? Understand that if you have blood group A, and then if it's homologous, it means that you have blood group A, and then it's like that. And then in that blood group A, we have B antibodies. And then if we mix the two, we are going to something like that. Then let's finish 2.3.4. Using your knowledge of sex chromosomes. Using your knowledge of sex chromosomes. You see here, it's like they are now escaping from the thing. And then, but explain why the sex of a child is determined by the male gametes. Explain why the sex of the child is determined by the male gametes. Simple. When now you come with your explanation and your understanding of meiosis, gametes, and then a monohybrid process, and you say, since they say 5 marks, okay, good. And then you are going to use your knowledge and but explain why the use of child is determined by the male gametes. You are going to use your knowledge. What knowledge are you going to use? You might come and say, a male figure have X and Y chromosome, ne? And the female figure has X and X chromosome. Tell me, if I were to give someone mark of someone who's saying I'm using my knowledge of sex chromosome to explain why the gametes of the child are determined by the father, why am I not obliged to give this person these 2 marks? Because his knowledge or her knowledge understand that in sex chromosome we have X and Y and X as a female. You have 2. From then you can play with words now. You can play with words. And then during meiosis, this will separate and this will separate, resulting in chances of X or of sperms with X and another sperm with Y. And then at the other side, the male ovum, either way, there will also be X involved. Ne? So when this X merge with the X at the ovum, the child will be a daughter. A daughter. And then when the Y from the father connect with one of the X that side, the son, the offspring will be a son. Ne? A offspring will be a male figure, and then here you'll say a female figure. Ne? And then that's how you are explaining. That's how we will expect you to explain why the sex of the child is determined by the male gametes. Where now by saying that these men have X and Y, and female have an X and X, you have your right hand. And then when you tell us that when this X merge with this X, we are going to have a female, it means you are saying that because you understand this, we will also give you another one. And when you say that when our Y merge with either X from the other female, the person will be a male figure, you are also going to get another one. Ne? And then you will now say, hence the male child or the child, the sex of the child is determined by the male gametes, because it will be dependent of these 2 from the male. The mother, either one, it doesn't care much. So when I'm explaining this, you can get your 5 marks. Ne? So it will depend on how you are playing with words. When the X and X meet, we are going to have a chance of a daughter. And then when X and Y meet, we are going to have a chances of being a son. And then these two are controlled by X, and X from the female, and X and Y from the mother. And then you might say that there another one where can we get it? We can get it during meiosis. We have sperm cells that they have X, and we have sperms that they have Y. Depending on which sperm it's going to reach the ovum first, that will be the determination of the gamete of the sex of the child. Here I told you, here I showed you, if this sperm cell go faster and then merge with one of the other side, we are going to have a daughter. And when this sperm cell, then it will depend on which one, these two. So with this dependent, where now you are explaining that this is why the males are the one that determine the sex of the baby. Get me? You get me, Matabade? Thank you. And then that was it with our 2015 question paper. Ne? Then the rest, it's what we can get. The pedigree, we'll do it next time. And then here I told you the thing. But 2015, we managed to answer 2.3. Let's move on. Ne? Let's move on to 2021. 2021, I told you that most of the time we will be focusing mostly on 2021, 2022, and 2023, since we are at this year school. And then 2021, we did 2015. Then 2021, November, paper 2. We are at paper 2 at this moment. At this moment, you know that we are in paper 2. Then let's move and find our questions. Then we can browse here. This is called scouting, or scanning. When you have a question paper, you can open it up until the last pages. And then while you are opening it, you will be now saying, okay, let me show you what we are going to do. How will we scan life science question paper? You'll open your question paper. Oh man, what am I doing? You'll open your question paper. Let me increase this. Not that much. Yeah, you'll open your question paper, and then there you go down. You say, okay, here you understand the question. Here we are dealing with a DNA reading, and then here we are dealing with chromosomes. But what that one, chromosome separation, meiosis. Then from meiosis, here you are doing with DNA transcription, translation thing with translate. That is what you are scanning before you can go to a question and see what the question requires from you. You can scan a question paper. Then you scan, you see the biological term. Then maybe you can just read one, the type of bond found between amino acid. Then you'll be peptide bond. Okay. Then you do question paper. They will need 3. And then from there you see this question 1.4. Now is the long questions. You see now here we are dealing with the DNA structure. The DNA structure, meiosis, crossing over. We have a crossing over. This is what you do when you scan your question paper. Then you have a crossing over. Then they will have questions that they will deal with that chiasma, what. And then here you see that here we are doing with dihybrid crosses, because we have 2 characteristics. We are going to do this tomorrow. And then from there you do see here transcription. Here this one is DNA transcription. Transcription and translation from DNA mRNA to protein. And then from there you move on. You see, and then there's our question karyotype and what. Here we are dealing with our question do pedigree. So we are also dealing with our pedigree. From pedigree, population, evolution, population, and then we're also going to do this, and then you know that our question paper is done. So in this question paper, we are not going to focus on eyes. Maybe an example, this one, it was November, last question paper. We don't have ears, we don't have what, so that's what we have. Then I also 2.5, we also have 2.5 here. So let's do this. We did this yesterday, but it was a question that was replicated from some documents. So I took that document and did it on our board, and then now I go and check our question paper. I found that question paper, or those exercises, they were there at the 2021 question paper. And then the diagram below represents the chromosome from the human somatic cells of a 2 individual who are twins. We did this, you remember, individual 1, individual 2, and then you can see here, that's when you see that now we are doing it. And then what are somatic cells? We did it. These are body cells. We did this, guys. You remember previously 2.3.2, name the specific type of chromosome numbered 1 up until 22. We did this SOMS, go and watch the previous question paper, the previous video. 2.3.3, each of the pairs shown in a homologous pair of chromosome, each of the pairs shown is a homologous chromosome pair of chromosome. Number 1, state the origin of each chromosome in a homologous pair during zygote formation. Zygote formation, you have 23 and you have 23, they match together. Where are these coming from? Yes, they say origin. I explained this, and then they are coming from the parents. They are coming from the parents, and the haploid, you can say haploid, or you can say one pair or pair one pair from the mother, female, and then another pair from the female. I get that a homologous pair. But state origin of each chromosome in a homologous pair. If we are seeing these two chromosomes, tell us where is this chromosome coming from, and where is this coming from. This one is coming from the father, and this one is coming from the mother. That's what I was trying to explain here. And then you may say it's coming from the parents, and say one chromosome from the father, one chromosome from the mother. Then number B, list 3 characteristics that chromosome in a homologous pair have in a common. Then you know that they have in common. What do they have in common? They have shape. What do they have in common? Or you can say length. What do they have in common? Their centromere are at the same position. Centromere, same position, and then they have same shape, same what, and then same gene. They have same gene or alleles. These are the homologous, and then their shape and length, and then they have the same centromeres, and then they have the same gametes. Then another thing, what do they have? I don't want to say things that I'm not sure with. Why did you do that? Okay, they have same size. They are the same size. They are the same shape. You can say size, you can say length, you can say. Then they have the same gene alleles, or they are the genes or the alleles. They are at the same locus. Because you might find they don't have the same gene here. Yeah, you might find that they don't have the same gene, but similar genes are at the same locus. And then another one, location of the centromere. And then we move on. 2.3.4. They say only 3. Explain one observable reason why the two individuals are not identical twins. And then they say, they say 3 marks. 3 marks, but they say explain. Explain one. You have to explain that one observation that you are saying. You have to explain that one observable reason why the two individuals are not the same. You might say pair number 23, pair number 23, individual 1. Let's say this one is individual. Yes, individual 1. Pair number 23, individual 1, chromosomes are not homologous. Then therefore it equals to this being a male. You are explaining one observable. Do you understand? This is the one observable reason. The observable reason is there why two are not identical. It's there, but explain it. We can see that these 23, they have a short one, and then these 23, both of them, they are big and big. We can see, but explain to us, what does that mean? And then you can say pair number 23, as you can see there, individual number 2, both chromosomes, they are homologous. And then this equals to X, and then equals to, she's a female. So these two, hence they are not identical twins, because the first one is a female, the first one is a male, and the second one is the female. Explain. They might say give one observable. Give one observable feature that indicate that the two individuals are not identical twin, or explain that one. Here, be careful. They want you to explain that one observable reason. 3 marks. then you can come 1 2, and then we're not giving that both of them, one is male, one is female, I can give you another one. So we move from here. I also marked 2.5. 2.5 here, use a genetic cross to show how gender in human offspring is determined by the sex chromosomes of the parent. 6 marks yamahala. Yo. So don't forget to write P1 phenotype. Don't write to and then male here. This one ki free, and then female here, and then you write the genotype. You write your thing and then you write meiosis. You write gametes. Oh, banabash. Use a genetic cross so to show how genetic gender in human offspring is determined by the sex chromosomes. Mana. And then you did your Punnett square. Let's give a Punnett square the moment to shine yana, because we are also going to do this Punnett square during a dihybrid cross. So you'll have to know what is happening in this Punnett square. Here we'll have gametes, and then here this gamete will come as it is, and these are the cells, Anir. Fertilization. Is it Z or S? Anyhow, any English that you are using. And then here we'll have X and X. These gametes, we are saying these are the ovum and the sperm. Then this will go that direction, this will go that direction, and then X and X, they will meet. And then X and Y, they will meet. Then X and X, they will meet. And X and Y, they will meet. X and X, they will meet. X and Y, they will meet. And X and X, they will meet. And X and Y. Give more Tomadipin. We are starting these songs, guys. You can sing it, Luan. X and X, they will meet. And then after that, you say F1 generation. F1 generation. And then you say genotype. Genotype. And then genotype, you'll say X and X. And then an X and X. And then X and Y. And then X and Y. Then we have 2. We have 2 is 2, which is 1 is 2, 1. And then you say phenotype. Phenotype, now you may say this one is a female, and then female, then male, then male, then the ratio 2 is 2, which is 1 is to 1. Hence, we always have 50% chance of a boy and 50% chance of a female. But they just say use a genetic cross to show how the genetic in the human offspring is determined by the sex chromosomes on a parent. Guys, you did this, you get your 6 marks. You did this, you get your free 6 marks. These 6 marks plus that 6 marks plus that 6 marks plus that 6 marks, guys, you can come up with 40%. This 40% is better than 0. This 40% is better than total fail. And we're now from this 40%, you are no longer being counted with those who we have more than 99 students who fail, 99,000 students who fail like it. And then we also have 88,000 students who passed with 30 up until 39%. So now if you get here, you are no longer we are count with the rest majority. So you get me? Why not just those simple, be like a haste man, be like a what do we call a robber, like be like you are robbing these people. The moment they give you that question paper, now check in that question paper, these two marks, these 6 marks I'm taking it, these 2 marks I'm taking it, these 5 marks I'm taking it, whether they like it or not. And I will make sure that where you find that you have your free 6 marks, make sure that you put your everything that you know. You put your F1, you have your P1, you have your F1, meiosis and fertilization. I have phenotype, I have genotype, I have gametes, I have genotype, I have phenotype, I have the ratios, everything is fine. Let's move on. 10 minutes left. Then 2021. Now we move to 2021. We now move to 2022. 2022 here. Paper 2. And then November again. So we go down, you scan. I told you how to scan. You scan. Let's use another example of scanning. We have pedigree. So you place your mind at pedigrees. Now you go and now unpack pedigree things. You know, I will teach you how to do pedigree, and then from there you have three chromosomes here, pair number 21. You go and unpack Down syndrome or one trisomy thing. Do you understand? That's how we scan. And then 2.4, you see a rabbit brown is dominant over the white long hair, and then we did this, and then this one is a dihybrid, and you do it tomorrow, and then it's fine. And then you scan here we are doing DNA, and then mRNA, we are going to say you have uracil, here you are going to have thymine. Those are the things, adenine, and then here you know adenine, thymine, because it's mRNA. You understand? They will ask you something to do with this. They will ask you to do with this X. You know, in this X we have phosphate. I didn't teach you, but your teacher teach you, and that's what you're supposed to have this knowledge. And then amino acid, you know, mRNA, they are going to code for a specific amino acid. You move on, you are scanning, and then here there will be a graph, and then I will have to unpack my understanding of the graphs, what the graphs are doing, the bar graph. This one, obvious, here we have more, here we have short. You go, and then you do your blood group. Did we do this? Calculate the value of X. Did we? 2.4. The table below shows information about blood groups in a certain population. Ne? And then they are saying blood group O, blood group A, blood group B, blood group AB, and then here's the percentage. But 2.4.1, how many people have the genotype I and I? How many people have the genotype I and I? And then yes, we know I and I is this, and number of people, this is the number of people. How many people have the genotype? And then you write 9, 5, 4, 1, 2, 3. And then this is the percentage of the population. Then if they have this population, it means that we have this population. And then we also what do we do? We also know, or we are aware, that this will be 3, 5, 6, 7, 8, 9, and then let's move on. 2.4.2, the population size is 1,800,000. Calculate the value of X. Show all calculation. And then we want the value of this X, which is A. Did we do this? I remember doing this. And then the calculation size is 1 million. Calculate the value of X. Show all calculation. And then we want this value of X, and then we have 1 million, but we have percentage. Yes, the percentage, we have 24. Then we're going to say 34 over 100 multiplied by, I'm not sure if this one is correct, but that's what the question wants. And 1, 2, 3, and then we are going to get the answer, and that answer will be something of this percentage. And 55 percentage is from this, and then this 10 percentage this, and then 3 percentage is this, and then 34% of this. You are going to multiply that, and we're going to have an answer. Let's do a calculator. We're going to say 1,008,12123 multiplied by 34% equals to 6. It means here we'll have 6. You said 6, man? 612,000. 612,123. Ne? And then 2.4.3, describe how a child inherits the blood group represented by a 3% of this population. 3% population is AB. Describe how a child inherits the blood group. It means that it inherits a 1 from the mother and 1 from the father. Ne? But describe how a child inherits the blood group represented by the 3%. We have to describe it. They are going to inherit a 1A from one parent and another B from another parent. Ne? And I'm not sure if I did that. Then I move on. This is what I saw prior to that question. And then let's move on. Let's do this 2.6. It says brown enamel. Brown enamel. What is brown enamel? Of the teeth is sex-linked. Sex-linked, you know. You see, we didn't do this blood enamel on our thing, but because they're saying it's sex-linked, it means we are going to link something here. And then a dominant allele on the X chromosome causes brown teeth in a human. Means that is controlled by the X. And then 2.6.1, explain why more males than females have white teeth. It means that this capital letter B and capital letter B, or capital letter B or small letter B, or small letter B and small letter B. Agree, but it is caused by a dominant allele. Mind you, when it is, I explained this. I remember saying this. If it is caused by a recessive allele, males are going to suffer the most. But if it's caused by a dominant allele, females are going to suffer the most. Why? Because in this situation they are suffering, in this situation they are suffering, and for them to have the normal thing, here they are saying the brown enamel, brown teeth, ne? Brown teeth is caused by a dominant allele. For them to have a white teeth here, for them to have a white teeth, they will have to inherit a small and a small. It means that from the father has to be like this. The father has to be white. And then the mother can be carrier. Or it can be, the mother can be both having an enamel. And for that child, the mother, we also want possibility. You see, when we did the possibilities, chances are that baby should be is there. So then you have to explain why more males than females have white teeth. Ne? You are explaining why more males than females have white teeth, because males, they will only need one recessive X-linked allele for them to be white, and females, they will need more, they will need two of them. So hence we find that males, we have more males that have white teeth compared to females that have white teeth. Ne? You explain this, you are now at the right gear. You become like, you explain this, you are now going you are now heading to a right direction, my guy. 4 marks there. 4 marks there. It means that you will have to play with words. Now, for me to come up with this explanation why more males than females have white teeth, this is the thing. This one is caused by a dominant. You can say this one is caused by a dominant. And since it's caused by a dominant, it will only need a male to inherit one recessive X from the mother for that male to be white. But for the females, they will need to inherit both from the mother and the mother for them to be white. So this one, the possibility of this, since they are less compared to possibility of this, hence we say this here, hence we find ourselves having more males having white teeth compared to females. Then 2.6.2, a man with brown teeth married a woman with a white teeth, but use a genetic cross to show the possible phenotype ratio of their children. Use XB for brown teeth and X small letter for a white teeth. Then we are going to say this because males sex linked, we don't contain the small y. And then with the female, she's going to be like this for her, because it's caused by a dominant allele. For her to have a white teeth, she'll have to have small two recessive alleles. Ne? And then from there we do our crosses. We are going to have XB with X small letter b, and then this and this and this and that. We're going to have X capital letter B with X small letter b, and then this and this, this and this and this and that. We are going to have X small letter b y and X small letter b y. Barry, show the possible phenotypic ratio. And then here we are going to have genotype to be like this, and the phenotype we are going to have a what we call a brown teeth. And then here we are going to have brown teeth female, and then we are going to have brown teeth female, and then we are going to have white teeth male, and then we are going to have white teeth male. So you see, ntate wa hao akaba le meno a brown. So wena as a man, you have to go and find a female who have white teeth for your sons to have white teeth. Nahanela bana ba hao. If when you have brown teeth, you have to go for some chick or some lady, female partner having a white teeth, so that your male's offsprings will have white teeth. Ne? So when if you have white teeth, possibilities, your female, your offspring, all of your offsprings will be white teeth. So they say show a possible phenotypic ratio. It means it will be 2:2, which will be 1:1. Then this will be a composite mark. They said phenotypic ratio. What the judge? We are tired now. Okay, let's finish strong. 2023. Nda, I'm coming. Oh, coming. Okay. Enda barmini. So, okay. Then uh, we have our Kim Venda. When Saliwa kwa Mr. Mpepo wa guy. Go and Google the surname Mr. Mpepo. You'll see. I'm a vendor boy. Kim Venda. Enda barmini. Mana kubulavula na skota. And kukhuluma siyakhona ukukhuluma. Nikuthetha siyathetha. Ubua. Sesotho. Ke ntho tsa gae ke ntho tsa rena re thathamela meriting ya letsatsi. And then Spedi, yeah, then Venda, ba re mene le macheloni le masiari ro ba tanganetsa kha nongonongo aretse. But my name is Nyombe, by the way. This is my name, Nyombe. Okay, it's fine. We want to talk about my name, we'll talk about my name and where I come from. Why not also comment on the comment section where you come from? What language are you speaking? Are you a Swati? Are you a Zulu? Are you a Pedi? Are you a Venda? Are you a Tsonga? Are you Swahili? Are you what? Where are you getting us from? The sugar found on a DNA molecule, we are scanning. The sugar found on a DNA molecule, you know, it's phosphate. Sugar, a deoxyribose, as kiss deoxyribose. And then we see this, then we see my meiosis there. This one is 2022 November, 2023 May, 2023 mid-year. Yeah, 2023 mid-year. Then, okay, then tRNA, our time is up. Alarm yalla. Alarm is ringing. Then mRNA codon, and then because I love you guys so much, I'll also include 2.6 or previous question paper, and you can also go and do 3.1. 3.1 when it deals with the graphs and what one. Then you'll have to learn the graphs, you'll have to understand. Then let me do 2.6, by the way. 2.6, yare. In humans, hemophilia is caused by a recessive allele on the X chromosome. So this is what I told you guys, Uri. Even when you don't know what is this sex-linked chromosome disorder, it's caused of, or it's what is happening with that sex-linked disorder, they will tell you, they will give you those information. Like here, they gave you an information. What is hemophilia? Well, now maybe you can just come and explain what is hemophilia. But from there you know. But a woman who is heterozygous for hemophilia marries a man with a hemophilia. And then we said when we write our, okay, let's move on. Use a genetic cross to show the percentage chances of the couple having a daughter who is homozygous for a normal blood clotting. So we'll want someone who will be like this. So let's do a cross section proving this or having a percentage for something like this. But a heterozygous woman, it's a sex linked, don't forget, it's a heterozygous H and Y. I told you that this book said we can start with a female and then come with then follow with a male. But now I will advise you guys to start with the information that you were given before or first. Now here we're given information about a woman. We're going to write a woman as like this. By this time you also under 2023. It was mid-year, so by this time they understood that you understand that whether they have a male or female that side or a female or male this side, it's not going to affect you. Small letter H. And then here we'll have X and Y, and they said he marries a male with hemophilia because it's caused by a recessive. We are going to say like this. Hence, the moment we do like this, we see that chances for this homologous female, for this homologous daughter, there's no way. This is not, because we'll need this H and capital letter H here, so for this to be homologous, so chances are 0% here. Whatever I'm doing, I'm just going to do it, but with a head full of 0% chance. Let's go and prove it. This X and X, this X and X, you write everything, guys. Don't forget. You write, if you write phenotype, then phenotype you'll say heterozygous, you'll say heterozygous hemophilia woman this side, and then here you'll say hemophilia male, ne, or you'll say a normal woman, and then they said because she has to have two small for that person to be hemophilia. Then we'll say X and X, this will meet X, and then we'll have capital letter H and small letter h, and then possibility number 2, it will be X and Y, capital letter H, and then here we'll have X and X, small letter h, and then here we'll have X, small letter h, and Y. And then the phenotypic here, she said carrier, and then here is normal. You know what is carrier name. And then here she is hemophilic, and then here is also hemophilic. So phenotype chances 25% carrier, 25% 25% female carrier, 25% female normal, and then 50% male hemophilic. So from here you can see that but use a genetic cross to show the percentage chances of a couple having a daughter who is homologous, and then the chances for that is 0%. You see how we answered that, Tanir? Then this 0%, this will be your compulsory mark, and then the 6 you'll get P1, and then F1, and then meiosis and the gametes, and then phenotype, genotype, gametes, fertilization, genotype, phenotype. Then you get your 4 from there. Then you have your 6. Ne? And thank you guys for that. We are done. Let me call it a day, guys. Let me call it a day. 1 hour we have done. We are at 1 hour time. And then question number 3, here we were dealing with the pie chart. Nothing much here. It was just an experiment thing because they asked you the aim. So this one, deal with an experiment, then state the aim of investigation. You know the aim of investigation, we find it there at the top. Explain the following questions, state 3 planning. You see, this one is an investigation, so we'll have a day where we'll do an investigation. Let's see, past question paper, video, and what, and then the same information. We have to do scientific investigations, ne? And then you'll do a test, and then you'll do a pedigree, and then you'll do this one is a informal assessment, and then it's either you can do a practical question on genetic crosses, or you can do past question exam question papers, ne? Then we'll go, and this question here we'll do it when we do a scientific investigation. Let's have that, let's agree on that. Or this one, if you want to do it you can do it, but let's have this the day when we'll be doing our practical examination, because it also wants you to state the reasons why did we include this, why the reliability of results, ne? Then in each and every experiment, you know what do we do as for that experiment to be reliable, ne? And then here we'll say conducting the 3 planning steps. What did we plan? And then calculate the number of participants that had group B show all waking, and then name the blood group which has only percentage alleles in there, has only recessive alleles. Then you learn percentage of this as a result of codominant. You'll want name the blood group which, and then this is it O, and then this one will be AB. That one does not even need you to go and understand, but give all the possible genotypes of a blood group represented by a 25% donor. And then which one is 25%? This is 25%, and then this will be like this or like this. Hey, and they said what? Give all the possible genotypes 2 marks again. Then let's do this fast. State the aim of investigation. But learners conducted an investigation to determine, and then here's will be the aim. Why are you doing that? You are doing this to determine which blood group was the most common in their community. That was the aim. They were doing this to determine this, the aim, and then they say they collected information about the blood group of 200 blood donors in each of the 3 clinic, 3 donor clinic. It means that we have 1, 2, 3, and then we took 200, we took 200, we took 200 in each of their community, and they did not include first time blood donors. The pie chart, it means that they went to a clinic, and then when they went to the clinic, they requested list of the blood donors, and then from those 200 list they check which one are they blood group A, which one are they blood group B, which one of those are blood group A, and which one of that are blood group O, and then they took the from the first clinic to the second clinic and the third clinic, they combine the results, and then they come up with this pie chart. And then the question state the aim here, answer the following question, state, and then we want 3 planning steps. State 3 planning steps to consider when conducting this investigation. What are the 3 steps that you can consider? When I give 3, what you can consider: one, you can ask permission between the clinic, and then number 2, another one that you have to consider, what is it? You can ask I'm tired. Ne? Then you can decide, that are the thing that you are going to plan. Like how many blood are we going to use? Like if you are saying you are going to use 1 liters, or what size sample size, 200, 200, whether we are going to have 200 people or we are going to have more people. These 200 numbers that we have here is the number that we use to sample. Like that's the number that we plan to say, okay, we are going to do this at 200 individuals. That was your first plan. Then another plan, we are going to do this at 3 donor clinics. That will be your other plan. Ne? And then another plan, let's have Barin, for you to be, you have to have a permission to move from to go from the school to the clinic. I'm not sure if I'm putting that right. And then number B, state 1 way in which the learners ensured the reliability of the results. By this time, you know what is being done for the reliability. What is being done for reliability in this? What will be the thing that they did in this experiment to make sure that this thing can be reliable? Is to sample same numbers at different clinics. So if maybe we came here and sample, they said 250, and then they go to the next clinic and say 259, and then they go to another clinic and say 200, the percentage or the numbers that they are going to compare, they won't be the same, and they are not going to have a reliable results. The only one way. And then number 2, give one reason. Number C, give one reason why they did not include the first time donor. You can say because they are going there to take the files. They are going there to acquire the files that have people's blood groups. So it means why they are not using the first time donor. It means that these first time donors, their blood groups, they haven't yet recorded in that file. I will have a file, we say Malibu aphiwe aphumelile, and then this one unali A, and then unali B, unali O. But the new ones, you might find that their blood are still now started to find the blood group. Hence they didn't use this. And then 3.1.3, calculate the number of participants that had blood group B. Show all your calculation. Blood group B, 15%. Then you are going to have 15% of something. It's 15% of what? We have two. That means 2 to 2 is 600. So out of these 600 individuals, we only had 15%. Then we are going to multiply this by 600, and we are going to have an answer here. And then name the blood group which we did this. And so guys, thank you. Sorry for wasting your time. You know, when it comes to time, I might be tired or I might be having time, but you know I love to teach you and make you understand this thing. So with that being said, guys, thank you. Let's meet again tomorrow, and then tomorrow we'll be doing dihybrid. So if you have any question regarding blood grouping, sex determination, sex linked, monohybrid, and the other one concept, feel free, WhatsApp me 071 190 6168. You can WhatsApp me privately, or you can go to the group, our group. We're at African Transcribers, guys. We can you can come and say, can you please add me to the group? I'll add you. So with that being said, thank you guys until we meet again tomorrow. I'm tired. Then tomorrow we'll be doing our dihybrid cross. Go and practice if you want to practice. And then maybe during the school hours you might be doing dihybrid cross. Then when we come back, we do a dihybrid cross. Ne? So dihybrid cross, we have two threads, a short guy, a tall guy. Example, tall guy with black skin. It's called with a short guy with a white skin. Then we want to cross this and this, dihybrid. No, we saw T B multiplied by small letter t, small letter t, small letter b, small letter b. Then before we come and say, hey, this and this, this and this, we are going to learn something new as dihybrid. Let's go. We're going to do dihybrid tomorrow. So guys, thank you. Dihybrid question and answer. Thank you guys. Comment, share, subscribe. Don't forget, guys. Don't forget to share. Don't forget to like. Don't forget to subscribe. Until we meet again. Peace. Vakane mkololo wa mpepo. Ndiye khali weduba. Nda.